Hello, everybody. Ho, ho, ho. It's Christmas soon. So that's why I'm pretty today. Uh, I want to say a couple of things before we get started on this quite long tutorial. I didn't plan it to be this long, but it is what it is. Uh, I want to say thank you. If you're watching this, you probably paid for actually watching this. So thank you very much. I appreciate it. Uh, some other things. I am including the trailer scenes in here. So the if you saw the trailer, which you probably did, they are here. I am going to have to remove the grass and the ground texture for that. It's Quixel. I'm just gonna put placeholders. So you can make an account on Quixel, or get grass from somewhere else if you feel like it. But it's not really part of the tutorial. And why the fuck is my... Okay, like that. What else was I gonna say? Yeah, so also the trailer scenes, they're kind of all over the place. Okay, so I did the trailer after I made the tutorial, which should probably do the other way around. So I was like going back and forth. So it's a bit of a mess. But if you want to check it out, you can do so. I did some tricks with the grass in the first scene. You can look at if you want to. Yeah, that's probably it. So hopefully you liked the tutorial, even though it's very long. So let's get started with importing our trees. So let's create a geo container here. This is going to be a blank box that we can put shit in. Let's call this init trees, and let's go in here. Now what you can do is, of course, do a file, and then we would link each tree like so, and then you copy this and so forth. So we have trees, but we can do it in a more fancy way. So let's do that. What we can do is a for each number, and with this we can say we have 4 trees, and since they start at 16, so we have trees 16, 17, 18, and 19. We're just going to say that it starts here, and then it's going to loop. So 16, 17, 18, 19. So we do this file import, and we can modify this. So since this field wants strings, we have to do the backtick thing. So that's shift, and then it's like the key next to the backspace. I don't know if American keyboards are probably different, but anyways, if we do 2 backticks, it's gonna basically, the result is going to be a string, even though we are getting a number. So what we can do is we can use a detail function, and the first thing we want to add is we want to go back. So that's /, and then if we start by saying 4, we can see that we have the count. So we're going to use that. And then the next one is I_value. That's the attribute that we want. And then we can just put a 0 on here. And let's also copy this here. And if we were to do this, we can see that it do work. let's just also package, we can just look at it. I'm just going to sample as well, just to create name attributes. We have that here. And then we can do a explode. And if we look here, we now have 4 trees. We have this, this, and this. So that's working just fine. So what is the I value? The I value is, if we look at this count block and go to details, we can see that here. We have the I value. This is going to be on the current iteration, because right now it's showing the last iteration. So if we do like so, a single pass, it gives us 16. And if we go to the next one, it's going to give us 17, and so on and so forth. Perfect. So are there some other things that we can do? I want to give each tree like an index that we can use. So let's do a primitive wrangle. There's not going to be a whole lot of wrangle stuff in this tutorial, but what I want to do is I want to give it a index value. So what we can do is we can actually take this, put this in the, well, any of them, I guess, but the second one. I'm just going to Shift S to make the lines nicer, I think. And what we can do is we can say I for integer at, and I'm going to call this tree ID, and equal. So anything after the equal is going to be put into this attribute, and we can access this attribute anywhere down the pipe, so to speak. Since this is details, and if you don't have this, you can go to let's see, which one is it? That's not it. Let's see, inspector. Oh yeah, geometry spreadsheet. So you should always have this on your screen. I think it's pretty useful. But since this is a detail, we can use the detail function. And the first thing that it wants is it wants to know where on these 4 dots the data is coming from. So it's on the second one. And in programming, you almost always start with 0. So it would be 1 here. That would actually mean the second input. The other one is going to be the I value that we looked at. And we can just put a 0 on this because it's a detail. We don't have a bunch of points here or anything. So if we do that, and we now look at this, we can now see we have 16 to 19. And it's put into our primitives. Perfect. So is there something else we can do? We are going to we're going to have to cap this, but we can do that later. I think everything is just flat on the ground, which is perfect. So we don't really have to do anything with that. I think I'm just going to remove one of the leaves, because the trees that we have here comes with 2 sets of leaves. And I'm just going to remove one of them, because I don't think we need all of it. I'm just going to use a blast, and we can say, let's see how it looks. Oh yeah, so I believe it's the 4. So if we were to say this, delete, we do non-select, yeah. So this is the one that we're deleting. If I believe 1 is also leaves. So I'm just gonna delete the 4th one. I think we have enough leaves for this. So now we only have that. So we have the name. It's going from, we have the tree ID. So that's the one of the trees, and then 1 being leaves, 2 being, can we get it here? Okay, 2 somewhere is the trunk. There we go. And then we have the branches. So we can have a look at it. Let's see. Do this. If we look at the branches, here we have the branches. And number 2 is going to be the trunk. And oh yeah, we can actually do this because we're just saying we want to do it on the 19th. So let's do the same thing here and use the detail. We're going to do the same thing that we did before. Go back 1 step, which is ... slash, and then we can for each count. And then it was I value and 0. And there we go. Now we should not have any force. So let's see. What are we doing wrong? Are we doing anything wrong? Boo, boo, boo. Okay, now we go. Let's see. We still have force. Oh, no. Delete, non-selected. Why are you doing this to me? One, two, three. Still have 4. 3. Oh, I'm dumb. So of course we need the backticks. There we go. Now it should work. We should now not have force. Yes. No force. Perfect. And what we can do now is let's do a null. Maybe we get back here later. I'm not sure. Out 3 import. So a null is just nothing. We can just select this easily, and out capital letters. It's just it's basically, if we look at object merge, for example, we click on this, we can see that it's at the top. It's just easier to find, but you do however you want to do it. But yeah, this is probably it for this one. Do we need anything else? Oh yeah, we can actually also set up a path before we move on to the next thing. So the path, I'm going to use the path for the rendering so we can easily just apply some materials. So, you know, the leaves going to have 1 path, the branch is going to have 1, and the trunk is going to have 1. So let's see. What do we want to do? Let's first, we can put this into a variable. So call this, it's an integer. Let's call this index. Paste that in here. Index should still work as intended. And now we can, I mean, really, we can just do this if we want to. So we can do s at name. If it's equal to 3 underscore, not sure if we can do this. Index. Maybe we can, I don't know. Who knows? We are getting this. So let's do a match. we use a match function. If match, and then we do the set name, and here we can do 3, or we can do 3 underscore. Let's see, what was it? So and then star 0, 1. Not sure if we press the F1 when we hold over a function, you see pattern sub. Okay, so subject should be kind of weird, but it should be here. And if it's number 1, it's leaves. So s at path equals leaf. And if we were to just copy this and do this, so 2, 3, and this is trunk, I think, and the third one is branch, like so. And if we look here now, we have trunk and leaf and branch. Perfect. To make sure I did it correctly, we can say branch, delete non-selected. That looks like a branch to me. Trunk looks like a trunk to me. Okay, cool. So we have this imported now, and we have path, which can be useful. And I suppose before we even go to the next step, I want to show you what I mean by this. I don't want to just like, I don't want to create everything without showing anything and then in the end show. So it's better to like, it's a bit slower, but I think it's better to just show. So let's do a SOP import. And let's take this. And here we can see we have this. So now we can easily, apply. And there's more ways of doing this there. This is one way. Just add a karma material. Okay, I can't do that. We have this clear auto, and then we can just, if we wanted, we can just drag it in like this. And that would like give us the material that we want. Cool. Yeah. That's that. So let's move on to the next phase. Okay, so we've done that. Now let's just prepare the trees a little bit. Let's again use the geometry box, prep trees. Then we do a object merge so that we can pick our trees. And now we got all the trees here. They're all at one place. So let's, obviously we don't want to do, we don't want to do more work than necessary. So let's do this in a loop. So we can do a name primitive. And the name, we're going to loop over, if I do this, it's going to loop over the name by default, which we don't want to do that. We want to loop over the tree ID. This will give us each tree. So we got that, we got that. So 4 trees. So now we can do some shit inside of our little loop. So first off, let's just split all of these things up. Blast. I like to use blast. And let's go with, I suppose we can use the path. And we're gonna go with the leaves. And we have the trunk. So first of all, as you can see, we need to cap this. We're gonna get some issues with the simulation otherwise. So we can do a poly cap and that'll fix that. Perfect. The leaves, I don't think we need to do much here with that. We are going to end up just merging all of these back down again. So let's just do that. So for the branches, what I want to do, I want to separate, I just want to like separate these. So all of these fine stuff we got here, we want to separate that. And also I want to keep like the thicker part. So let's add a measure. And let's see what we can do. Per piece, we don't have that, so we can do a... I'm not sure if we need... Let's try it without it. And it's area greater than 1, let's say. Set it to primitive. And not that. Yeah. Let's do a connectivity. So what a connectivity is doing is pieces that aren't welded together, it's gonna get a class in this case. Let's do it on the primitive. That's fine. And then we can set per piece, class, and here we go. So now, if I, change these values, we're gonna get a thicker part. So anything area over 0.2 is going to be here. So we can see if we look at the area, what I want to do is, I think it's better to just do a split on this one. Do it like this. I'm gonna paste that in here. That's not primitive, just because. Give it a null. Large, small. And if we look here, we got all of these. And then we got all of these. This is probably pretty fine, I think. Let's see. And I'm gonna do that. I'm gonna bring these guys in here. Now I want to be able to actually separate these, because right now they are all, there's nothing here that can kind of differentiate them. Maybe the class, but what I'm gonna do is we can do maybe a group. Let's just call these, I don't know, large branches. And then we can do a small branches like so. This way we can split these up later if we need to, which is great. maybe we should do an attribute delete to delete stuff that we don't need. So for example, class and yeah, area. So now we no longer have those attributes because we probably don't need them. And you know, it's nice to be tidy when you can. So something that we might want to do, I'm not even sure if we need to use this, but let's do a poly reduce on these guys. Maybe 50%. Maybe that was too much. Let's just, yeah, that's fine. And now I believe we have prepared them. Let it do its thing. So we can take a look and see if multi-threading this is beneficial. So because when you do a for each like this, it's not going to be multi-threaded. So you would need to do it like this. Cancel and turn on this. Let's see. I believe it needs to do some shit before it gets faster. Let's see. We're not getting any issues at least. So let's see. Do this. I don't know. No, I don't know if it's faster. We can see. So not all blocks are compatible. So they're gonna have this kind of icon if it's not compatible. But it looks like everything is compatible. So maybe it's a little bit faster. But it's not always going to be faster to multi-thread something. But maybe this is. So let's see. Should we file cache this maybe? We can do so. Yes, everything is there. We might go back to this, I don't know. But this is at least the initial setup. I'm gonna call this prep race. And we don't want to do a time dependent because that's gonna cache every frame that we have here. We just want to cache it out once. So untick the time dependent and then just save to disk. And there we go. Okay, cool. Let's call this out prep trees. And there we go. That should be all for our little preparation, hopefully. We'll see. You know, sometimes you have to go back because you forget things. I'm kind of doing this on top of my head. So we got that. Perfect. So now we are going to fracture our trees. So why are we fracturing when we, like, what's the point of that? Why we're doing it is because we're going to use RBD simulation for this to get the trees to kind of sway and bend. And of course, some of that's just going to snap off because the RBD solver is not going to move polygons. That's why we have to fracture it. and then using hard or soft constraints to kind of keep it together but still bend. There are, of course, other ways of making dynamic trees. I believe the most optimized way is to use the wire solver, but that requires us to have nice looking splines where the the trees, so it's going to use a wire or a line, and these are these are not trees that I made here. Now, if you are making a tree in Houdini, you probably are getting those kind of splines. Same thing with, like, I don't know, Speed Tree or something. I can't remember if that's the correct name for the program. But I think you get splines with that that could be used. And to create splines out of pre-made trees, it's doable, but it's a bit of a setup. So that's why I'm going with the RBD approach. There, of course, vellum. You could use vellum when using vellum. You don't actually need that because it's going to create constraints for each polygon or point. But we're going to use RBD, except for the leaves. The leaves are going to be using. We're going to use vellum for that. So let's get started with the fracturing of this. Again, let's do a trees. Let's call it fracture trees. And again, object merge. Let's pick the one that we did, which is the prep. We got it here. And once again, we are going to use a name primitive loop and set this to 3 index or ID. I think it was. Let's do that. And there we go. Perfect. Looking good. So again, we need to split things up using a blast. Blazed from the paste. Leaves. Do this. So we got the leaves. And then remove that. And we're going to do the branch. And we are going to do the trunk. So we got these 2 things or 3 things. This should also have the grouping, so we can do that. Just to be prepared here. Large. And let's create a null. Large and small. I don't think we need to use the small in our simulation. We will see. Not sure. We can also do a merge in the end. I'm gonna merge them all for now. Like so. Shift S. Where do we start? Let's see. We can start with this one. So, one thing to keep in mind is the more pieces you have, the slower the simulation is going to be. So we don't just want to scatter a bunch of points. So what I'm thinking is if we can try to make points that kind of form a spline, and then we reduce the points so it's not too many. So let's see. Can we use a attribute blur maybe? Let's see. Something like this, perhaps. Not sure which one is the best here. And then let's do an add. Just remove. Now we just have the points. That's fine, I think. And then we can do a fuse to remove some points. And there we go. We have not too many. think that might be good. So we are like, we could have created, we could create constraints in here, but I think it's just easier to make another loop for the constraints, because we might want to tweak the constraints more than we would need to tweak this. And it also becomes less complicated. So I'm going to use a Voronoi fracture, which is like the, you know, the old school one. We don't need to have a bunch of what's it called? We don't need like get rid of the Voronoi of it. Let's do an explode and let's have a look. This is what we have now. Maybe that's too much. Maybe something like this. Should we look at another tree? That's how that looks. I think it's kind of okay. Something like this. Yeah, let's go with that. There we go. And whoops. You can press Y to get this scissor, and you can just cut wires off. I'm gonna drag this in here. There we go. We want to set up the names as well. So we can have this as overwritten, I think. So trunk, we call it trunk. Now, we don't want to just do this, okay? If we do, let's just, I'm gonna drag this in for now. And if we remove this, we're gonna have an issue. And that is, everything is called, like, it repeats itself. So we have trunk 0 here, and we have trunk 0 here. So they're all kind of repeating. We can't have that in a solver. They all need to be unique. So we need to fix that, but that's an easy fix. Let's just do a single pass. And I'm thinking it's probably best to just do it in the end, because we just want to add in a number, which is the iteration. And if we click on this create meta import node, this is going to give us this, going to give us some extra stuff in the details. So what we have here, we have the iteration, we have number of iteration and value. So we can go with either iteration or value. Not sure which one we should use, but I guess it depends. Do we want to have 0 to 4 or 6 to 9? What's it called now? Let's see, trunk. Maybe we should go with value then. Let's try that. Oh, by the way, we don't actually need to do that. I don't think we need that, because guess what? We have the tree ID, so we can just use that. So we're gonna do s at name. We can do, I think we can do plus equal, and then plus equal. Can we even do this? I mean, it seems like it works. So can we do I at tree ID? We probably need to use I to A. I to A. Is that the one? Let's press F1. Is it integer to converts integer to string? Yes. Let's see. Okay, cool. So now the name is going to get that 3 ID. And if we take a look again, now they should all be unique. So then it goes to 17. Or were they already? Oh, god damn it! They were already unique. Ah, no, wait. I'm looking at this. Let's see, trunk. There it is. Okay, yeah. So that. I'm gonna do this so we can actually see what the fuck is going on. Trunk 0, 16, and then it ends up to 17. There's the 17. Okay, perfect. So that, I believe, works. And let's see, let's do a single pass again. Merge that in. What we probably want to do as well is, if we fracture these, what I'm thinking is I want to constraint this. Like these need constraints, of course, all of these pieces, but I also want them to constrain to this. Okay, so they are not going to be like whatever if we want to break them or not. But then we have stuff here that we also constrained. If we break this, those can kind of get destroyed. So let's do a scatter. So it's just gonna scatter a bunch of points. I don't know how many, but let's do that. Vor fracture. So you can do like, so it's not relaxed. Now it's gonna be more random, but I think we can go with this. Then we have this. Now we have a bunch of pieces here. Not sure if we need that many. Let's do 50 maybe. Now we have to look at names here again. So what I'm thinking is let's remove the small ones completely, so we're not bringing that in. So we skip that for now at least. We'll see. Because obviously this is gonna up the simulation time and whatnot. And it's small pieces. Small pieces are always a bit annoying, but let's see. Branch. Not branch. Branch. Then we got that. And of course, this is going to create that extra unique identifier. Let's just remove the leaves for now. Let's have a look. So we have trunk and we should have branch. Cool. Of course, this is not, we need to have it on all of our trees. But it should be all fine. Cool. But we also need to bring these with us. And I believe that is it for now for the fracturing. So what we have left is creating our constraints, and after that we're going to do some simulations and whatnot. Not the file cache. I'm going to cache this out and say trees fractures. That's okay. Not time dependent again. Save that out and do a null. And we're going to say out fractured trees. Make sure to save. I think that is good for now. Maybe we need to go back. We'll see. Yep. So let's just create a simple little setup here. We have a box, we have a sphere, and we have a, let's say, torus. Okay. And I'm just gonna move these somewhere like that. This can be, I can see it. Like so. Let's just merge these as well. Of course, you wouldn't manually create constraints, but I'm gonna do it just to show. We do need to have name on these because the constraints needs the names, and of course also the solver need to have a name. Let's just call this what it is. This is a box. This is a sphere. I can't spell today. Sphere. And this is a torus. So we got that. And let's now let's create the constraints. So I'm just going to manually do it like I said. You wouldn't do this, but because this is really all it is. A constraint is just a line with 2 points. And the 2 points need to match the name attribute of what it's attached to. So if we do something like that, maybe, let's make another one for this, like so. And let's again, create a name. So if we look at the points, this one has 2 points, of course. And what do we want to do? So the number 1 is on the torus, number 0 is on a sphere. So if we just say group 0 and say sphere, it's going to select point number 0. And then we can do again, say 1, and this is, can't spell torus. And if we look at this, this is of course needs to be on the point for our constraints. So now this have sphere and torus for the name attributes, and they are matching. And we need to do the same thing here and see 0 is on box. So let's do that. Box, and this is on a sphere. Did I do this correct? Yes. Cool. So few more things. It needs to have a rest length. That is basically just saying how long is this constraint. We can just do a measure, do length, and just call this rest length. And then do the same thing here. This is on the primitive itself. This is 1. This, I guess all these are 1s. Length, yeah. But I mean, if we made it bigger, it would be, do that. And we have that. Cool. There's a few more things that we need, but we can do, we can merge these first. So we have them all. And now let's just, it's just easier to do it with a primitive wrangle, I think. This is basically now we're going to say on the primitive itself what it is. So what's the name? That's the constraint name. It can be anything, but we can just use what is set on by default. So it's a string. It's called constraint underscore name equal, and by default, if you want to have a hard constraint, it's capital H hard. And there's another thing we need, and that is constraint type. And here we can say either all, rot, rotation only, or position only. Let's do position only. And I think that's it for hard constraint. If you were to use glue, you would have strength as well. But let's see. Let's assemble these guys because they need to be packed. And of course, important is to not create new name attributes, because if we do that, our constraints are no longer going to work. they need to match, right? So let's unclick this, create packed, fine. And I'm just gonna move this up in the air, and I'm just gonna Control Shift Alt to create an instance of this. So this will move as well. So let's just put this 3 maybe, like so. Let's make a collider like so, that's fine. I'm just gonna Control C to copy that. And now we need to have a dot network. Just drag that in like so. Perfecto. So first packed, we're gonna do more of this later. This is on the first context. And then we need a rigid body solver. We need a constraint network. We need a hard constraint relationship. Shift S to make it nice. What else? We can do a merge and do a static object for our collider. Just gonna paste that in the box and make sure that the collider is first, otherwise it's not gonna work. Or you set this to mutual and now it's gonna work no matter what. If we hide this and just see second, yeah, it works. Otherwise we wouldn't be getting this. We are getting an issue though. Let's see what it is. Pause. So that's not the real name. Let's see. Let's do a RB RBD constraint property. I just want to see like what's it called? Hard. If I do pause. Okay, so they spell it out completely. Huh. Okay. Let's do that. Position, like so. And let's just add a gravity here as well. And if we were to play, we have constraints. It all works. Cool. That's really all it is. There are, of course, more attributes that you can put on your constraints and all, but like the most basic of the basic, this is it. Again, you would not create constraints like this manually, maybe on a special occasion, but obviously that's not what we're gonna do. We're gonna automate it, of course. But that's just to show how simple it is. Demystify it. I don't know. Just for anyone that doesn't know. So we've fractured it, and now we need to create the constraints. So again, a geometry. Let's call this constraints degrees. Let's go in here, and we of course gonna have to get our trees. Out fracture trees. Cool. We want to do this in a loop because we don't want to manually do this on all of them. So a for each name primitive. Pipe that in here. And of course, we don't want to do it on the name. We want to do it on tree ID. So now we're looping all the 4 trees that we have. So let's, I don't know, let's pick this one to see. And let's, first off, we want to separate these. And I think we can just use, so we can say leaf, delete unselected. We have that here. This would be, is it trunk? Let's see. Yes, and then we have branches. Not branches, branch. Okay. There we go. And let's also just merge these in now while we're at it. And let's see, if you hold down Alt, you can create an anchor. So it's not in the way. Let's start off with the trunk. Easy way to do this is RB the constraint from rules. We can do it like this. And we also need a RBD, let's see, what is it? RBD constraint properties. Pipe that in here, like so. We do a null, just to see. This is our constraint. I want to have this at hard. Let's call this hard trunk. So that's the name of our constraints for this. We can target this in a solver in the DOP network if we want to. Okay, that's probably fine. And I think this is fine as well. What I'm going to do, we're going to say this is the yield. And then we can make another merge that is all the constraints like so. And then we make another merge. And here we merge these guys in. I also want to do a group actually, so we can target our constraints if we want to. So let's just call this constraints. So now all of our constraints that comes in here is going to have a group called constraints. It's not needed maybe, but it's a good thing to have. Let's do for branches as well. I'm just going to copy this like so. Let's call this trunk and this is branches. Let's call it maybe branch. That's probably fine as well. And now we also want to have, a stitching between these. So the stitches here. And I'm thinking this can be glue and unbreakable. So what we can do is, like the easiest way I think is just to like make a temporary group. Call this 2, that's fine. This one can be 2, like so. And then we merge these guys in. So now we have all of the Yeo here. And just gonna copy this again. And we're gonna set this to group 2, and group 3. So now we have the stitches only. And we can set this to glue. They can be stitches. And also set this to -1 for unlimited strength. And here we're just gonna take the constraints, which are the pink ones. So that's constraint. It's going to complain because some mismatch attribute doesn't matter. For example, glue has strength and the hard constraint do not. So that's good. Let's see. Perfect. I think it's all good. And if we now turn this off and let it do its thing. And let's do a drop test just to see how rigid our tree is. Maybe we can just file cache. And I know I'm file caching the yield again. We already cached it, but I don't care. Kind of just cache all of it. Trees. Done. Maybe. Turn off the time dependencies, save the disk. Now we have it. Let's see. I want to just use one tree. And let's see, we can use a 3ID. So 3ID equal, I don't know, 19 maybe? Delete not selected. Let's go with this. That's fine. And let's also blast away the leaves for now. We're not going to simulate the leaves using RBD. Those are going to be vellum. So we're going to have to do a sim on this, and then we sim the leaves separately. Cool. And let's do a split. So we split out the constraints. Let's do like so. And say constraint name equal empty. Did we not have constraints? Let's see. Well, we don't have this. We need that. Let's see. What have I done? Oh, we have it here. We have it there. Oh, okay. So, yeah. So the 3ID, we also want to have that here. So let's do a primitive wrangle. And here we can use the metadata we looked at before. This is a different metadata, but we have the value here. So we can just use that. Just take this and drag it into our second input here. And let's just say I at 3ID equal detail function. And it was the second input, so it's 1. And it was value, and then just 0 because it's a detail. So, and now we should have, where are you? 3ID. Perfect. Now let's just save this to disk again. Now we have it. And because we did constraint name, if it's empty, it's going to basically be geo. If it's not empty, well, then it's a constraint. I mean, we could have, I did create a constraint. Maybe that's even better. I don't know. Let's say, what's the point of creating groups if you're not going to use it? Okay, so let's use it. Geo. And there we go. So what I want to do as well, since it's a drop test, let's just move it up. Move it up 5 meters, probably fine. And since we're going to use the RBD, we want to pack our object. We can do that with an assemble, the easiest way of doing it. And we need to uncheck the name attribute so it's not creating new, and then packed primitives. Let's drop down a DOP network. Just going to do this. So Yeo is on first one, constraints on the second one. And here we do the pack object. We need a rigid body solver. We need a constraint network. We want to have a merge. We want to have a ground. Otherwise, it's not going to work. And we need another merge. And we need 2 hard constraints and a glue constraint. Drop this in here. And what do we call them? Hard trunk. And this is hard branch, I think. And glue underscore stitches. Set this to 1. Otherwise it's going to multiply with whatever we have in here. So let's just do that. Put that into the second input. This is where our constraints goes. And now this was in the second input, and this is on the first input. And of course do this, and we can see that it works. The red one is glues, and these guys is hard constraints. We don't really need to see it. You don't want to simulate with showing this, it's going to be slower. So if we were to, let's just test. Well, we actually need a force or a gravity. What's nice about pop gravity instead of the regular gravity that you would put here is that we can target groups and whatnot, so find it more useful. Negative 9.8, and this is not what we want to see, right? This doesn't look good. If we were to even change this to the bigger tree, which is this, I think, it's like, that's not how a tree looks. I've never seen a tree being dropped, but I can imagine that's not how it looks. So, of course, adding more constraints can make something more rigid, but the more constraints you have, the slower it's going to get. So right now we just have max one per piece, which I think is fine. What we can do is remove the whole dynamic, like the compute mass shit, and just have mass at 1. And well, I'm also gonna just remove the bond. This has nothing to do with it, but I'm gonna do it anyways. So mass at 1, and then we can set a custom mass. And let's see, we can do that here. So let's do a primitive wrangle maybe. And then we can just target I guess we can target the path. Let's do that. So if s at path equal trunk, if that's true, then we can do a mass of, let's make this, have more mass. And then we have the branches is going to have less mass. Not patch, path, I think it is. And this was branches, I think. Mass equal 1, let's say. So let's just see. Trunk, branch. Okay, branch. Boom, boom, boom. That seems to work. So this is a float. That's why you don't have to. You can have a F in front, but you don't need to. It's gonna assume that you're wanting a float. But everything else you need, like, so path, I think, yeah. So there are some things that doesn't require it, I think, but for the most part, you want to say the type. But this is not a Vex tutorial, so. One thing though is that we don't actually have them yet. So let's do an attribute promote and just promote the mass to be a point. I just did it on the primitives because we have the path on the primitives. So it's just easier to do it this way, I think, and then just promote it to a point. And then we do need to also transfer this. So right now it only keeps the name, but if we do a mass, you can see that we do get the mass. So if we take a look now, I don't know what's wrong now. Let's see, what did I do wrong? Okay, I did. The mass by. Okay, I clearly have done something wrong. What did I do? Well, this is awkward. Wait, does it work now? Huh. So I didn't do anything? You don't know. Who knows? Mass. Now we should have mass. If we were to play this now, it's a lot more rigid, right? It actually holds. We are going to fix this later. But yeah, seems to work quite nicely. And before we're done with the constraint chapter, even though this is not really, well, I guess this has to do with constraints. We can make it break as well. Let's just do that. So we need a subsolver. So hard constraints are not like glue. Glue is gonna break based on the strength that it has and on the impact. But hard constraints and glue constraints are just never gonna break unless we specifically say so. So it's on a primitive wrangle because the constraints here are on the primitive. So I'm thinking I'm not going to break the trunks and I'm not going to break the glue because I put it at -1. We're just going to do the branches. So we're going to say if s at constraint name equal this. If that's the case, then we can just, we actually have to say as well. So we can say, and we can use angle, for example, greater than, let's make a variable. Let's call it, let's just call it angle equal, and then we create a channel. Call it whatever you want. If it's greater than angle, then we put them in group broken, which is a known group, like this. And if they are in the group broken, they are going to disappear. So click on this. This way we get our channel here, our angle. And let's just give it a value. I don't know what we need. And they kind of fall off. Cool. Now there are more shit here. So if we look, we have angle, but we also have like, we have distance, we have force, impact. Maybe we can also use impact. What we can do, if we know that we're only gonna have this, we can just do, we can basically say if, not that, if not hard branch, return. So if that's the case, then just don't do whatever is here. And then we can just do this. Maybe this is a bit cleaner. I don't know. So up to you to decide, where we can say if that's the case, or what we're going to do, impact. Impact greater than, let's create another one, impact. And of course you can name these whatever else. I'm bad with names. Let's call it impact. So if this is true or this is true. So what was the maximum here? Let's just say 10. I think that's too much, but I just want to see when it kind of falls down here. Just thinking maybe we want it to break some more. Oh shit. That's a lot of. Maybe it is breaking. That's probably fine. It shouldn't be or I mean and. So, and now both needs to be true. Yeah, exactly. So we're definitely going to use or like that. That's fine. Maybe set this to 2. Now I'm just playing around. Boom. Cool. That's that. That's our little demo. Let's tidy this up so you can download. You can have a decent file to look at later. Demo. C for color, make it black. That's nice. Okay. Let's also, before we end this chapter, yes, I call it chapter. It's professional. Out. Trees. Done. Cool. Go up. Save. And yeah, so now we're gonna do some simulations and we're gonna add the leaves in. Okay. Okay, so now let's create a demo scene with some simulation. Again, use the yield. Let's call this, I don't know, demo multiple trees. And before so I don't forget, we're gonna object merge this, but this doesn't have the mask that we created here in this little demo. So I'm just gonna copy that, paste it in, and do this. So now we do have the mask somewhere. Well, somewhere we should have it. Let's go in here and do an object merge and just merge this. I believe this was the correct one. Yeah, so we have a bunch of zeros, but that's just because constraints are merged in together, and if they don't have a mask, they're gonna get a default of 0. So what we did here in this demo, we had 1 tree, right? Okay, I guess I had 2, but they are different, so they all work. It's all gonna work nicely. The problem though is going to be when we have duplicates of these trees, because the names on the constraints and on the geo is going to be duplicates. So we need to fix that somehow, and it's pretty simple. So let's first create a grid so we can scatter some points, and let's scatter 10 trees. I don't know, we can look at that and see 30, 60 maybe more. No, let's do 30, 80. That's fine. We got that. I'm just gonna add a collider as well while we add it. Make that bigger. Let's make it a polygon. Let's move it up somewhere around here for now. And now what we're gonna do, we're gonna scatter these onto these with a copy to points. Now we do have to do some things first. Yeah, we're gonna have to randomize the trees. That's called attribute adjust integer. We can use that. This is gonna give us, well, by default it's gonna give us a variant. And if we set it to random, we go 16 to 19 because that's what we have here in our tree ID. 16 to 19. It's gonna randomly give us a number between 16 and 19. as we can see here. But let's just call this 3ID, I think it's gonna work. And also I believe we're gonna need to do 3ID. Let's see if I'm correct. Looks like that's correct. So now we're getting some random trees. We could also randomize the orientation of these. This one. Let's try that one. And say orient. Orient is a 4 values. Let's set the, let's see which one is it. Oh, it's this one. I don't know if we can do this maybe. This should give us a random rotation on these guys. Did I do it right? Yes. This one looks like so, and this one looks a bit different. So that worked. And now we can go ahead and just fix this. Let's make it bigger. And let's see, move it up a little. I'm just gonna alt click, and then we can do, let's do 60, 36 and move this here. And then we can just make a keyframe there as well. So now it goes through. I don't know if it actually hits everything. That's fine, it doesn't need to hit everything. Cool, we got that. So about the unique name, what we can do is we can actually turn on an ID here. This is gonna give us an ID 0 to 9. So we had 10 points. So 0 to 9, that's 10. And just for simplicity's sake, we can just do an attribute promote and just get this ID to primitive as well, and just do not delete originals. Now we have them both. And we can do a split. So we can split out the constraints like so. I think that works. This is the constraints. This would be the hue. Perfect. And of course, we are going to blast away the leaves, because the leaves are going to be simulated in a second simulation using Vellum. So now we have that. What do we need to do? Yeah, let's attribute promote, and let's promote the mass. I think we need to do that. So now we have it on the points. And as you can see, we have a bunch of attributes here. I just want to clean that up. A lot of these attributes comes from the constraints, and we have them here as well, of course, but we want to have them here. But I'm just going to do a delete attribute and basically just, I mean, you can do this star and then you do this up thingy, but I'm just going to select them here. So otherwise this is going to go faster for me. Impulse. We can do number iteration. We don't need that. Propagate rate, this, and rest length we don't need. Strength we don't need. So now we have cleaned this up a little bit, and let's just do the same thing here. and say we want to remove the name here, because we do have the name, but since these are constraints, we want to have the name on the points for each constraints, and we do have that. That can be still here. Yeah, let's just keep that as is now. So now about the making the names unique. Let's do a wrangle. And we're gonna do that. Okay, let's just remove the name here as well on the points, just to clean it up. We're gonna pack it, so it's gonna get the names that we have on the primitives onto points, but just to be clean. We have the 3 ID. No, we have the ID, that's the one. Let's put that on the name. So that would be, you know, s at name. And then we can use a function called sprintf. This is basically, we can say s %, so string. This might be the opposite, but let's try it. Then let's just say ID 3 underscore maybe, and then we do an I %. This means that these are placeholders. So this means that it now requires 2 variables or attributes here, or, you know, anything you would say, but you probably would use a variable or attribute. So the first one is just going to be the name. So we get the name that we have. And the other one is going to be the ID. And if we look, see if I did it right. Oh, it's on the primitive. Yep, it was the wrong order. I always do it. $, I for integer, and there we go. So now we have this, you know, ID underscore was it, then the ID. Now I'm just going to copy this one, and I'm going to do the same thing, but on the points. And that should be fine. And then just to not get any issues, because you can get some issues by having like the ID. So I'm just going to remove any like ID shits. So now we don't have an ID, which is good. Now we can just pack this with an assembly or assemble. Do not create new attributes or new names. And we're gonna have to promote the mass, otherwise we're not gonna have it, because it's like packed away. If we, you know, it's gonna take the tree and it's gonna be like, or pieces, it's gonna pack it, and it's basically gonna hide everything. So if we want to have the mass, we're gonna have to like take the attribute and put it on our little container box here. That's fine. And let's just do a dot network. Gonna put this in here. And I'm just going to Control C, this one, the collider. So we have it. And we're gonna start with the packed. We need a rigid body solver. We need a constraint network, a merge, a ground, probably. And we also need a static object, which is going to be our sphere. Let's turn this into mutual so we don't have to care about the order. And here I'm just going to paste the sphere in. Remember to turn on use deform geometry, because we have it animated. Otherwise it's just going to, well, not going to do anything. And here is the first context. This was the second context. And we have 3 constraints if I'm not way off. So let's add a merge, put that in the constraint. And now we can just do a hard and alt click drag to make a copy of that. And we need a glue constraint relationship as well. Take this, put it in the merge. Now let's see if I can remember. Trunk, I think was called, hard trunk. This was called hard branch. And this was glue stitches, I think. Set this to once, so it's not going to multiply anything. The glues one are a -1, so they're just going to be, you know, never break basically. As we can see, it works because we can see the constraints. It's going to complain otherwise. And before, yeah, we might want to have a gravity as well. That would be a pop force. Put that in here and do a negative or minus 9.8. Let's look at what we have, and it works, and they are unique. If they weren't unique, then when this sphere would hit this one, because that's exactly the same, it would, you know, deform the same way that this does. So it clearly works. We want to stick them to the ground. Oh, before I remember or forget, the mass. We need to uncheck this and use this as mass. So we actually get the proper weight of everything. This is what we get. It's pretty slow. We can do something about that, but let's first do a attribute wrangle just to stick these to the ground. So we can do a shorthand. We do active, the active attribute, which is a known attribute from the solver. So if it's 1, it's going to be active. If it's 0, it's not going to move. It's still going to be collided with, but it's not going to move. So we can do a shorthand if, basically an if else. So if we look at, so we can say, okay, so position, so at p dot y, looking at the height up and down, right? And if you are greater than 2, be 1. And as we know, it's going to default everything else to 0. So you can't have, like, you're not going to have an attribute on some and then not on others. Okay, if you have them merged into the same line here, or if you were to have like different things coming into the merge, and you only have attributes on these guys, these ones are going to get it as well because they get merged, and it's just going to default to 0. Unless it's a string, it's going to be default to empty. So that's that. Let's also, I like to do a dop import. We can drag it into the network here. And right now it says star, which is basically show me everything or get everything. But let's just take the RBD packed. And like always, you know, you can use like RBD and then wild, like a star, which is basically like, oh, anything. So we can do that. And this is what we have now. Maybe before, you know, obviously like we're going to have some issues like this. We're going to have to fix, this is going to have to be meshed with a point deform. So we're going to have to fix that. Obviously, like we have to adjust our animation, our collider or whatever to not stretch it, which might look really, it could look bad. Even if you do a point deform to mesh it all together. Yeah, that's you just have to plan your animation a little. But we could maybe make this a bit less. And let's see, I'm not gonna have any bounce on our trees. And let's just not have any bounce on this one. We can lower the friction. I don't think it's gonna do anything for us, but you know, who knows? So that's that. Yeah. So what about kind of optimizing this a little, because it's kind of slow. Well, before we do that, okay, sorry about going back and forth here, but let's just make them break as well. So since we're using a hard constraint, we're gonna have to tell it to break. Otherwise, it's not gonna break. If you have a glue, you don't need that. It's gonna use the strength to basically, because when you get an impact, it's gonna have like some sort of force or whatnot in the attributes, and if it's go above your strength, it's just gonna break it. But that's not gonna happen on soft or hard constraints. So what we can do is we can take this relationship geometry, and since we are on primitives, we need a primitive wrangle, and we can say, we can target, because I just want to do this on the hard underscore branch. Everything else I don't want to break. So we're going to do s at constraint name. If it's equal to hard, what was the name? Branch. And then we can also do, we can test it on the angle, which I like to do. If I can spell. Angle, if it's greater than something, let's do 0.4. We can do this, and then we can do at group broken equal 1. So this is a known group for the solver. So if anything is inside of this group, then it's just going to delete the constraints. And this is how you do a group. If you want to add something to a group, you have to say at group underscore, and then this, whatever comes after the underscore is going to be the name of the group. So that's just how you do it. Let's have a look and see if it's fine. It definitely does its thing. This one is, I kind of want to just, let's just do another seed. I want to see if we can get something better. Maybe that one. Let's see what we get. That looks better. Boom. I don't like this, but fuck it. That can be the way it is. This should really probably break, but we're not going to do that. That's then we're going to complicate things, especially since we are going to have to point deform this. So let's do that in another video maybe. So that's what we get. It's pretty slow. So the easiest way, which is the way we're going to do it, just to keep things simple, is going to be adding switches for the constraints. So what we can do, we can say, hey, start off as a glue constraint, and once you break, become hard, or become a hard constraint. That's gonna probably give us a ×3, ×4 speed increase, because the rigid body solver is going to treat anything that is glued as kind of one thing. So if you had a sphere and then you fracture that in 1,000 pieces, but then you glued it together, it's almost going to be as quick to simulate that as if it were, a non-fractured sphere. So it's pretty fast. So that's the easiest way of just doing it. So we're gonna have to go back to our constraints, and we are going to just have to change this. So I'm just gonna copy this one, do a glue, let's call it glue trunk, and this is gonna be a hard one. Paste that in, and then strength can be 10. And then we're gonna, well, this, we don't have to do anything on the glue ones. We do the same thing here. I'm going to copy that. Go for that. So the glue, it start off as hard brown. Well, this is actually glue branch, and this is going to be hard branch. It can be a 10 strength. Let's see if this is correct. Glue trunk. Okay, perfect. Let's just save this to disk. So we're caching it. We have it on file now. Perfecto. And of course, you know, now we have some more constraints. And we can look, can see. Do a constraint. Oh. Do this. We can see we have a next constraint. So we can see it start off as glue underscore trunk. When it breaks, it's going to be a hard trunk. So I just want to see so that we don't have any weird position. That's fine. Yes. Now we just have to add these in here. So let's take the glue and just alt click drag to copy it. And this was called glue trunk. And this was glue branch. And we just need to copy this in. And if we were to simulate now, let's hope it works. See how much faster it is? It's quite a lot faster. I want to kind of see how fast it is. Let's just look at, I'm going to disable these. And oh my God, I'm going to have to do this again. Disable hard. Sorry about that. I want to see it. So hard branch, perfect. Save this to disk again, or whatever. Let's have a look. We're getting 3-ish. And of course, the more we have, the let's see, we do 20. And let's just do this, and we are getting 1. And it's probably going to be slower and slower, or maybe not. I mean, it's not bad, but it's slower. So say 1.2. And now we do the switching and say enable this glue. So glue trunk, hard trunk, perfect. Switch constraints, glue, that's fine. Cache it. Let me see now. Okay, what are we getting? 2. Okay, wow. It wasn't that much faster. I guess it's sometimes faster. I don't know. It's been faster when I've tried it. Let's see. Anyways, that is one way of getting a bit faster. That's weird that it's not like... Oh, now it's fat. Okay. Oh, okay. I'm stupid. That was already cached. Anyways, at least from my test, except for this one, we are getting, we should be getting some like faster results. We did get faster when we did this. Maybe it's because they were so close, so they kind of breaking right away or something. So let's just do that. Another way would, of course, be to like just set everything to active 0, and then you basically do a check to see the distance from our collider in this case. And if you are close enough, activate, and you probably then want to activate the whole tree and not just whatever piece is close. But for this, I'm gonna stick with the switching. I think that's fine. So is there anything else? Yeah, I guess we can just take a look at the point deforming. But I think we have to make these guys deform more. Yeah, okay. Let's cache it. Cool. So we have that. Okay, so we're gonna have to deal with this. And we're gonna use the point deform for this. Now, so let's see. Point deform. So here's the mesh to deform, right? We need to get that. So where is it? I believe it's here. Here we got the prep trees before it gets fractured. Yeah, that's cool. And we're gonna do a object merge and just paste that in here. So now we have that. So all we need to do, we need to place these guys exactly where these guys are that we are simulating with. So let's copy this one. And now they should be exactly the same, which is good. And let's see, let's just promote this one as well, because we need to also create the names. We have names somewhere. Why am I not seeing any names? Oh, because I have that on. We have names somewhere. Here we have it. So we just have to basically copy this. Well, then that's done on a point. Let's take this one. And now they get, the ID onto their name, so we can match it in the point deform. Another thing we need to do is we need to remove some shit here. So let's do that. Because we only want to do this on the trunk. So I'm going to do that. So now we only have the trunks. And let's see, that might be it for that. We're gonna have to unpack our stuff here. So what I'm gonna do is do a time shift, because I do not want to do this every frame. So let's just, how you do it? Let's see, Control Shift to remove the keyframe. So it's just on frame number 1. I'm gonna do unpack. And I think we're gonna need to promote the name, or get the name. And I believe, well, we're gonna have to blast away. Again, I think we should only have the trunk. Trunk, revert that like that. And then we do a transform pieces. And here we have the geometry we want to transform, which is going to be this. And this is the, let's see, the rest point is probably going to be, let's see, how is this? This is always a bit of a mind bender. Let's see. So this is the geometry we want to transform, which is this. Here we have that shit. Uh, uh. Yeah, what? We need to do this? No, we can't do that. Template points. Okay, so that was it. So now we are doing something with this. We are deforming it. Or no, we're not deforming it. We're transforming it. The unpacked stuff. So now we're running unpacked shit. I'm just doing it on the first frame. And then I'm gonna take this, put it here. I think we need a rest point. That's not it. Let's see. Ba-ba-ba. This is always. I think we need to promote the name. That shouldn't be it. Nah. Let's see. Deform points, which would be. This is definitely the deforming points. This is the rest, which is. Ah, okay. Like so, and there we go. Like that. This is always, I don't know, I always struggle with this one. And then, of course, we would do this probably. Revert this again so we get this. And we got something like so. That's probably correct. And now we can merge these guys in. Like so, and now we have all of it. Now you see this. This is like, you know, not looking too good. We could, of course, smooth it out. But I think, I mean, the big issue here is in the actual simulation, right? So we can see it's like snaps, which basically means that we could probably have more fractures on the branches, or we can make it not as strong. I think that could be a way. And if we like lower this maybe, and then we take a look again, there's barely any snapping now. But that might not be what we want, because now maybe we want the angle to be 0.4. I'm thinking, can we use impact or something? Let's see, what do we have? We have force, we have impact. Let's just take a look. Impact, let's go with impact. Let's see, this 0.4. So we do an angle, and if we do these in like this, then we can say or impact greater than 10,000, maybe. And if we look now, are we gonna have the snapping? I don't know what the impact is. Yeah, that's better. So now we still have, maybe the impact should be even higher. Let's try 30,000. Yeah, let's go with that. That's fine, I think. Boom. I mean, I'm not too happy with that. I'm just gonna copy this one. Remove that. Let's also, let's just pin this. This way we can be anywhere. That's the snapping, right? So maybe it is fine. 100,000. Yeah, let's go with 100,000. That's cool. So this basically say it needs to be this constraint name, and then since it's within these guys, it basically say, well, if your angle is higher than this or impact is higher than this, then, you know, break or go in here, anything. And this could also be done as a one-liner like that as well. I don't know if that actually is just too much code. Let's do this again. And let's remove this. And let's have a look. Just gonna go to the last frame. And here we go. Now, of course, a lot of this is also going to be hidden. I mean, I know that it's stretching. That's just what's going to happen. Unless we break it, but then it's a bit of a pain in the ass to break things and still keep it like with the point deform. It could be something we can look at in a later video. But yeah, cool. I think we can do one more scene, and then we can do the vellum part. Another thing, of course, as well, that you might you know, get into is that because we have pop force instead of a gravity, we can say like, you know, have underscore force, for example, and then we can do a pop wrangle or geometry wrangle, and then we can say like we can do a speed variable, and to get speed we could say in the length drop in the velocity. This is going to give us some sort of value for speed, and then we can just say you know, if speed greater than 0.1 or something, then group, was it have force? Not face. Force. Let's see, was it that? Have force, yes. You never know. And then, of course, also you want to kind of like, if you not explanation, whatever this is called, this is basically the reverse. So if you don't have force group, then, you know, do the check. But if you have it, then I don't want you to look here anymore. And so now nothing has gravity until it starts moving. And we could even lower this, you never know. But cool. That's that for that. Yeah, let's do one more example, and then we do develop. Okay, so the worst thing that can happen when you make a video is that you realize that some of your clips do not have sound, which is what happened to the Shaky demo part, which is basically the setup and the the point deform. So what we're going to do is I'm just going to go through it, and because it's fairly similar. So let's just go through the nodes. So what we got here is, okay, so the idea is to have a shaky tree, right? So if we look at this, we got a shaky tree. Cool, looking good, funky. So we're importing our trees. I'm blasting away everything but ID 18.3. So that's this tree. Oh, I fucking hate saying tree. 3. It's hard. Okay, so we're blasting away the leaves because we're not going to have them in this simulation. We're splitting it out like we have done before with our group. We have the constraints, and on the other side we have our Yeo. Perfect. We are just, packing it, exposing the mass, and making sure not, creating new name attributes, because that would of course fuck everything up when it comes to the constraints. We're also promoting the mass so that it goes over to the points, because we are on point, because we're packed it. So and then I'm feeding that into the .NET. Let's go over the rest. The other one, this is the driver. So I just have a box. I centered it. You see it below. I mean, it doesn't matter. Like giving it a name box. I am packing it. Let's see what else. I animated it as well somewhere. So here we are basically saying don't be active. Okay, so it's not going to really do much. Have it deforming though, because we are animating it here. So what I've done is basically right click, motion effect, and I picked a noise, and it's going to create this motion effect thing. So, you can then, you get some parameters and whatnot, and just noise it up. And that gives us this. I'm doing it on both translate and rotate. Funky. And just putting it in the third input. And then what I do as well is here we are creating constraints. This would be the constraint. There's going to be a glue with the strength of, let's see. Come on, there you go. -1, so unlimited strength. Calling it anim. I am using this, so instead of creating a group, I'm just doing name box and then not name box, which is basically going to give us this stitching that we've done before, but we did it with groups. This is actually nicer. That's really that. And this goes into the rest of our constraints. I believe that's that. And if we then look at our .NET, we are adding in our constraints that we've done before. The only thing that is different is our new constraints, which is called the anim. We have our tree, making sure the mass, and by the way, rotational stiffness is also something that you can use to kind of stiffen up the constraints, or in this case, the tree. We have, I shouldn't do that. We have the anim. This is the animated box. And I don't know, bounce probably doesn't matter. Maybe it does. We have some force. I mean, the rigid body is the same. This is the same as well, just, doing this whole when it should break. And that's it for that. And we get some shaky tree. I mean, we can try to do, let's just go overboard with it. See how much stiffer it is now? So I don't know why, like on the trailer scene files that, or trailer notes that you can see how I made a trailer for this, you'll see that I use some values for the rotational stiffness. So this is definitely something that you can use. Let's do super stiff. So that's really nice. Well, let's just have it at 1 because that's what I had in the video that doesn't have fucking sound. So let's go over the point deform again. Like I said in the previous here, I had no sound, so I'm just gonna go over the point deform as well. And after that, everything kind of continues as it should. God damn it. So we have, again, we're bringing in our .NET, just dragging that into the .NET field here. We're saying we want the trees, perfecto. Then we time shift it because you don't want to do these things each frame, okay? Like you can save a shitload of calculation slowdowns by doing this whole time shift transform pieces thing. So by having this here, we then blast away shit that we don't want. We unpack it, and then we want to transform. So we want these guys to kind of drive our unpacked shit that we have here, right? And then we do the whole, we do the point deform on, let's see. So this is the rest point. So these are the unbroken trees, I believe. Yeah, out prep trees, unbroken, they aren't fractured. We're blasting away, we're just keeping the tree number 18, removing, here we have the leaves, and here we keep the trunk, and then we can then deform this with the help of our transformed shit. And we're doing this just so for the deform, like instead of having packed, I don't think you can do, yeah, it's gonna be weird if you don't pack it, because if you're packing, if you have it packed, each piece is gonna be like 1 point. Everything is gonna be treated as, a single little point. So that's why we unpack it, so it kind of deforms properly. We give it some velocity for rendering, because we're losing it somewhere. I guess we're losing it here. Yeah, so that's that. We're also doing the whole unpacking thing. This might not be necessary for the leaves. They might be able to still constrain to packed, but I'm doing it anyways. And then we just do the transform piece shit again. This is always like a mind fuck every time. I've done this so many times, and every time it's like I'm doing it the wrong way until I'm doing it right. That's just how it goes. And then we're just merging these in, removing some shit that we don't need. You don't have to do this, but when you file cache, when you cache things, the more attributes you have, the bigger the file size, and also the slower it's going to be to to play back here in the viewport. So really, like if we wanted to, we could skip the velocity here and do that after. So we're not, because right now we're caching, we're getting the velocity, and that's in the file, which, you know, that's a 3 value kind of thing that is changing all the time. That's going to increase. So you could do this afterwards if you want to like save up on disk space. And the rest is vellum. And for that, I don't need to go through. We can kind of continue on as we should have. Okay, so let's do the whole leaves thing on the Shaky tree to begin with. We got this. So one thing that we might want to do as well, if we look at this, we don't actually have any velocity on this one. So I think you can do an attribute copy on these guys because these one have it. We're just not getting it with the point deform. And if we were to do V, we get it. I think this will work. It's gonna get the correct ones. Obviously, in this case, we only have one tree, but on the multiple ones that we did, then, you know, I think it's gonna work. But you can always just do a trail stop and then just compute velocity, and we now have velocity. And these should already have it, yes. This the point deform that doesn't seem to want to bring in anything. No? Okay, anyways, back to our leaves. We have the leaves here, so I'm just gonna do an object merge, bring that in here, so we have it here. And if we wanna, you know, optimize it a little bit, we could do so. Not sure if I did it in my second one, but we can actually, I've done this before, and it's like, yeah, it works. We're gonna get a class for each primitive, and each leaf is basically just one primitive. But you shouldn't have to do that. We can just do a primitive wrangle and do an if, and then once again, I think I took a break, so I can't remember what I did previously. But rand is going to give you a value between 0 and 1, a float value based on a seed. So if we do a prim num, which is the primitive number, and if you're greater than 0.1, for example, we can do remove prim 0 for the first input, because that's what we do here. It's the prim num I want to remove, and 1 basically removes any points as well. If we don't do that, we set this to 0, you can see that we still have the points, which can be useful, but in this case, no. So let's lower this for now. Maybe we can just have it at 1 for now. What we want to do is we want to create constraints for the actual leaves. And I'm going to go with a cloth, vellum cloth. And so I've gotten better. I've gotten better results by having uniformed mass, much less stress stretching, because we don't want to have a bunch of stretching on our leaves. So we're gonna have to look at that, see if this makes it decent. Let's have it for like that for now, and we can have a vellum constraint, and this is going to be, could just remove this. This is gonna be for the tree. And let's see, we can just put that in here and say attach to geometry, and just do that. Let's just in case attach on frame 1. You can see it's not like, it's not perfect, you know, because if you have more leaves, it's going to be fuller, and you're not going to see that the leaves aren't actually connected to the branch. We did remove the small branches, so I mean, if you want to play around with having the small branches as well, you can do so. Let's see, we want to have a break, so whatever the break is, I'm not sure. We can also say a max distance. So let's say maybe 1.1. Let's go with that. And we do a vellum solver. Now we're going to use the SOP vellums like you see here, but in the other one with the more trees, we're going to use the DOP network to do the vellum, just for a variation. And you know, yeah, we're going to have to do a lot more on the bigger scene because of memory constraints. I'm going to show you some things we can do here as well, other than just like removing, you know, maybe you don't want to have all of them. I'm gonna do this again for now, and let's see what we can do. Well, in this case, this is gonna move right away, right? So it's gonna shake. So let's just have gravity on all the time. That's fine. We have self collision. If you wanna, you know, make a faster simulation, you can remove that so that the leaves aren't colliding on itself. Let's see. Let's just put on a ground plane. What happens if we play this? Well, not much. Let's see. I don't think it's that. This. Okay, so it was losing way too easily, and it still is. Let's see, 50. I don't want to have too many leaves leaving the tree. Maybe we should increase this. Not that one. Let's see, 72 maybe. Like so. Looks kind of cool, I think. We have loosen branches as well. Let's just also merge so it looks nicer. We take the leaves and we take our shaky tree. Now we can see it in its full glory. Looks kind of cool, I think. We can maybe add some drag. So if you double click on the solver, we get into this little thing. Not pop force. Let's do a drag. And a pop, drag, spin maybe. And here, I don't know the value, so let's just keep it a default and see what we get. This is not really a scripted tutorial other than me. I mean, obviously I've been playing around with it, so I'm not completely fresh to it, but I think it looks kind of nice. What if we, obviously you want to see it in its full glory, I know. You don't have to scream at me. It's a lot slower now. So what if we What if I show you a way we can do this with a lot less memory, and we kind of keep it as is because it was kind of okay. Yeah. So what we want to do is we want to cache this out. So let's say, should we cache everything out or just keep the leave? We can just cache out the leaves maybe. So let's create a file cache. Put this in here. So we have the only the leaves. And why are you? Let's see, is it there? Sometimes you have to reset it. So if you have labs installed, you can just like reset viewport. Otherwise, you would basically create a new what is it, viewer, scene view, and remove the old one. But if you should have labs installed, it's quite nice. Let's just call this cache me. Let's see what else. Not sure if this matters in this case, what we're going to do now, but I'm just going to set it to 0. This basically means that it's, oh, come on. It's not going to, we're not going to get a blue line, as you can see here. So it's not like storing shit in the memory, but I don't think this actually matters. Wow, what did I do now? Jesus. Sorry about that. But we do it anyways. I haven't tested it to see, but it's fine. It's fine. So we have cache me. I'm going to just save the file. And what else do we need to do? So we have 72. That's probably fine. I'm gonna cancel out of this. Let's remove this. This is the tutorial path. I'm just gonna copy this path and I will go into the command line tool and D colon. I'm on Windows, so it's a bit different on Linux and Mac. At least some things are. So we can do CD, that works on Linux and Mac. I'm just going to paste in my file, my path to my folder. And if we do a dir or ls, if you're on Mac Linux, we can see we have our file here, trees, hip lc, and we have our directories. To get into trees and like start an instance, what we can do is we do hscript, if I can spell, and then trees.hiplc. And if we now press enter, it's going to start an instance and we now are inside of our project. So now we can use Linux commands. So ls will basically list everything here in the root, which, as you can see, we have, obj, shop, image, mat, all of those things. So what I'm going to do is I'm going to go into obj and ls again. It was called demo shaky trees. So we can do cd demo underscore shaky trees. What did I do wrong? Let's see. Oh, tree. Of course, it's just one tree. So ls this, and we get all of our nodes and shit like that. So we can go into cache me. So now we're actually inside here. And now we can't actually see. I know I've tested this on Mac, I think, and you could actually see what's in here, but on Windows, I can't see it. But whatever, it doesn't matter. There's a node called render in this cache node. So the command is render. And what do we want to render? Well, we want to render the render node that is inside of this. And if I just enter this, it's going to basically it's going to do our caching, and it's gonna just tick here and might we can look at the Yeo, cache me. We can see that it is working. And I'm just gonna fast forward so you don't have to see this. But this, well, I can first say why you would do this is because you don't have to have regular Houdini open, which means that it's using a lot less memory. We don't need to see the UI and all of that shit. So as well, we can actually start Houdini up again while this is doing its thing, and you can load in the frames that we have, so you don't have to wait for it. But of course, it kind of defeats the purpose of using the command line, I suppose. But let's go in here. Let's go to our shaky tree and do a file. And then just look at the cache me. Take this. And this is now what we got. I'm just gonna make sure that it's not gonna simulate anything. Cool. This is what we got. Let's merge this. Y to get the scissor. And I think it looks kind of all right. I like it. So one thing that I didn't do, which I should have done, is remove a bunch of shitty attributes that we don't need, that the solver needs when it do its thing. But there's plenty of things here that really you don't need. You can keep the velocity. Otherwise, I mean, it's going to everything you save here. It's going to increase the file sizes that you're caching, and also it's going to make it slower to play back here. So the less you have, the faster. But there are, of course, some things like velocity, for example, which you might want to have when you render. So you can keep it, or you can not keep it, just to make the file size smaller, and just generate the velocity with a trail saw and just turning on velocity. But there's plenty of shit here that you don't need. Pretty much almost everything. But I didn't do it. You can do it here in the save filter, or you can do a what's it called, attribute delete. You can do it here as well and choose which you want to delete. But I didn't do it, but now you know. And I think that is all for this. I kind of like it. It looks cool. Shaky. So the next one is going to be a little bit bigger. We're going to have to deal with a lot more trees, a lot more leaves. Okay, let's create the leaves for these multiple trees. I did a few things behind the scenes. I reanimated this, so it's a bit slower, and do some wiggly waggly, because it was going like over 100 meters in like 1.5 seconds. It was just crushing the leaves. The leaves were flying everywhere. It was just a cloud. And I also removed the ID here because we were not getting the IDs on our branches. So that was a problem, because I want to be able to remove certain trees. And I cached it. And I also made sure to actually remove the ID for our trunks, because if you have it on, it's not going to deform. It's not going to work. So just making sure that we remove those. So now I also did this. We now have as the way we want it. This is for so that we can easily we can fix the constraints for the leaves, making sure that they aren't getting like constraints on other trees. I created this. So we have all our trees, and we also do need the leaves here. I just want to do this in a separate node. Take the leaves. And let's just call this out all leaves. Like so, I think that's fine. Let's do a node. Call this demo multiple trees leaves or something. Make it a color. We need to object merge. Let's pick our leaves and our trunks. Let's name this leaves, trunks, and branches. We have our stuff here. Let's make this bigger. Got some nice trees going, all working nice and fine. We're gonna do something with the leaves. So we're gonna start off with a blast. So what this is gonna do is that we're gonna simulate each tree separately because we have a lot of leaves, and it's just like it's gonna crash Houdini if you don't have enough memory. I don't have enough memory to simulate these trees, so that's why we're gonna do it one after the other. But we're gonna set this up in what's it called, tasks. But for now, we can just say ID2, let's say, so we can test. And then we can set up a primitive wrangle like we've done previously. Rand prim num greater than what's something 6. Remove prim first input, so 0. Prim num, and then just 1 for all the points. And now we have less. So let's set up the cloth vellum. And let's see. I've had more luck with set uniform, although this probably not going to matter because we are still going to get stretching. We didn't get stretching in the previous example, but in this one it's a bit more extreme. Things are moving faster, so we're going to get into problem with stretching, so we're going to have to look into that. This is probably fine. And let's add a vellum constraint. I can remove this, not using it. We're gonna pipe it in here. It doesn't matter, but do it again anyways. This is going to be on attached to geometry, and we're gonna attach it to these guys, or one of them. So if we Control Shift Alt to create an instance, as you can see, it's like this, or a reference, I suppose. So anything we change here is going to be changed there. So this is good. This is the current simulated one, right? We're also going to do this again, and then we're just going to delete this and reverse it. So now we have all of these guys, and we have this. If we just do this, we're going to get into an issue. And if I move in here, you can see it's attaching to our trunk. Luckily, we have a group that we created previously, and it's large branch. And let's just call this pin. And if we now pick, if you can update yourself, there we go, pin, and now it removes. Cool. Let's just set this to like 2 or something. I'm gonna lower this a little bit. And we're gonna set breaking threshold to, I don't know, 800. That's that. I said we're gonna use the DOP network for this one. You don't have to, but just for variation's sake. Drag this in here. Drag the collision in here, there, here or there. Can't speak. Let's do a merge as well. So we can merge in the rest of our colliders. For now, I'm just going to disable this. Can enable this later. Vellum solver, of course. We need a vellum object. We need a vellum source. Put this in like this. It says object here, and here it doesn't say anything. It doesn't say source at least, but that's where you want to have it. The other one is force. So while we're at it, let's create a force. And we want to have a merge, so we can add in our ground and our static object, which is going to be our 3 colliders. Set this to mutual, so we don't have to care about the order here. And since we did put them into these inputs, instead of like, you know, doing this, and then you could like paste that in here, that would work. But just to show you how we can do it without that, it's kind of like the pact. I don't know why they don't have this selection in here, but they don't. So backtick and then up input path, the function. We go up 1 step, so // and then in the second one is so comma and then 0. So that would be the first input. You can just paste that in here and set this to 1. So now we have the constraints. And we can also take this, paste that in here too. And there we go. Of course, we're not seeing all of them, but if we were to do this, we now have all of them. Let's just remove them for now. Like so. So I was playing around with the instance point, but it was not doing much in terms of memory for me. So that's why, you know, in case you're thinking about it, I didn't have much luck with it. So yeah, that's where we're gonna do them separately. They'll simulate each 3 separately. We can just hide this, doesn't matter. For the force, what I want to do is I want to set a group here. So only if you have this group have force, you will have gravity. And add a pop wrangle. And we can do this in one line. So we check if length and put in a velocity here. This is going to give us a speed value. If you're greater than 0.5 or whatever, then you want to go into group have underscore force equal 1. I also want to make sure that they never get the force removed. So we can just say only do this if you're not in force, or if you not have force. That's probably okay. Let's add a drag, pop drag. and a drag spin maybe. 0.05, air resistance 1. Yeah, that's fine. If we were to play this now, what are we gonna get? Let's see. See if we can see the stretching as well. It's just it's a lot more an extreme thing here. That's why we are going to get stretching, most likely. Maybe not on this tree, but on some trees we are going to get leaves that are stretched. We don't want that. And there we have a stretch one. Look at these guys. Stretchy, stretch, stretch. So one way to solve this is, hopefully it's going to be solved, because that's something I played around with, is we can remove self-collision, by the way. That is like the leaf can collide with itself, but I think that's unnecessary. What we can do is, if we had a point wrangle here before, and we can just do an attribute called disable external. I think that's the one. So let's see. I want to make sure. If we were to play this now, it's a lot faster. And we should not have any stretching. I don't see any stretching, at least. Because now they are not going to be able to collide. Like, the leaves are not going to be able to collide with other leaves. It's still going to collide with everything else, because we specifically said that, don't collide with leaves, basically. But the tree trunks and floor, for example, it all works fine. I think this is a good, like, trade-off to not get a bunch of dumb stretching. So that's that. Let's add in this. Let's just do a play blast. Can we, let's see. I was thinking, maybe we could add so that they can collide if they're far away from their original position. We could try that, but let's just do a play blast first. Let's do that. Looks kind of cool when they follow the branches that broke. Kind of like it. I think it looks pretty all right. We can just give this the try. This a try with this thing. And because I wonder if we can, like, store, so, or do we have original position? Maybe we already have it. We don't have it here, so maybe we can just, like v at for vector or a pause, store the position here. I have no idea if this actually works. Let's also, we can remove this for now and say if, let's see, Let's create a distance. So float distance distance function with orig pos and your own position. And then if distance, if it's been like, I don't know, this is 25, so 15. So if distance further than 15, then what was it called? Disable external 0. Is it correct? Let's make sure. Can't spell. Don't kill me. Okay, so let's have a look at the issues here. We're not actually going to get this the way I've done it here. We don't need it. I've tried it with this, the whole enabling the collision between leaves, but it's still going to give you stretching. But this is actually not going to happen because of this force group. Because this is going to happen way sooner than anything else, and therefore they're going to get this group, and we're basically saying don't look inside of here if you have the have force class, which basically means that we're not actually like doing any of this, which is fine because that's trash anyways. It doesn't work. So you can skip basically this. This is not important. This, however, is, of course. And I think this is good thing to have. It's going to be faster to calculate, just to check if it's in a group. That's faster than every frame running this function to get like a speed value and then do the check. It's just better to have this, so we don't have to do this if they already have force. So yeah, but this is not needed. And also, we have a lot of leaves. Why even have collision between them? That's kind of crazy. So it was good. Let's just give this. I don't know even if we are gonna be able to actually see. Did we get stretching now? No. I'm seeing stretching everywhere. So we should have, we can just give it a try and say if you're greater than 0.01, which basically should give us stretching again, just to see if it actually works. I don't know if it does. Oh, I saw a stretch. Here we see a bunch of stretching. There we go. So what if we do 50? So this was like 21. Click on this, let it do its thing. Are you not doing anything? Okay, there we go. Okay, now we don't have stretching. So I think it works. Maybe this could be something. Maybe 15 meters isn't, I mean, maybe we don't even have to have 15 meters. It has to go, I don't know, 5 meters. So we're still gonna be getting some collision. Looks like it works. I can't really see, I don't really actually know if it actually works, but I would assume it does. So let's just leave it on, and if the end result gives us stretch, then you can always play with the distance or not do this at all. Okay. Let's see. We want to do an DOP import. So we can just pick our vellum like that. Let's also make sure to pick this one. Let's attribute delete as well. We don't have to save all of this. There's plenty of shit that we don't need. We can just delete everything except for maybe V. What else do we want to have? Let's keep 3ID as well. 3ID. It's gonna save some disk space, and not that I think that this actually requires that much, but I'm keeping ID as well. Hopefully this is okay. Should we have W, which is spin? Let's just keep that as well. Why not? What else do we have here? Let's just keep these. And these we want to have. I guess we could remove these guys as well. Group delete. Have force. This. I don't dare to remove too much, so we have to like redo some things. But yeah, let's just keep that, and let's also make sure to have a file cache and pick explicit. So now we're gonna be fixing the file caching. First of all, I want to have more. Fuck it, I'm just gonna go with all of it. Why not? You only live once, so you know gotta treat yourself sometime. Collision, that's good. It's all good here. This could also help for stretching, but I put in extreme values. I still saw some stretching, by the way. So, and upping the substeps is a solution, but this doesn't, like, it's going to increase your simulation type by like, I don't know, 10 or something, like crazy. And at least for this setup, because we have so many leaves and they are overlapping, and it's just not good. It's much better to have it one, so it's not as accurate, because you're gonna get some explosions and whatnot. So yeah, we got that. I'm gonna save, go into tasks, topnet. Make sure to you know, either pick a custom amount of CPU cores to use, or use everyone but -1. And this is going to be a very simple one. This is probably the simplest one that you've ever seen. These tutorials usually are pretty advanced, I think. We want to have a for each loop. I don't know if we need an output, but I'm putting it there anyways. And in here, we are going to use a fetch rup. And that's all the nodes that we need. So we're gonna, oh yeah, let's just, so it's easier for us, name this. Cache me leaves, please. You can press N to kind of move around, but for some reason they don't have everything. So you still have to go here to tasks. Maybe you can, maybe that can be modified. Who knows? We go to this, cashmere leaves, please. Yes, and we are going to Ibiza, or we're gonna do frame range. Let's go with frame range. And also, we're gonna have this on. So all frames in one batch. That's my dog. This is something you want to have in simulation. I believe also, like, we want to make sure that we only, like, we want to do one job at a time. So we don't want this to work on several trees in one go, because we want to save memory. Okay, we want to use as little amount of memory as possible. So that's probably okay, I think. Yeah. Let's go to this. So we want to use the loop iteration. This would be this. And then we're going to modify this. So I'm going to copy this one. And we're going to put that in where we need it to be. So one place would be here, all right? So this is static right now. So we do backtick and you add loop iter. We're going to get an issue. That's because we haven't like generated it yet. But we're going to do that soon. And here I'm going to say, let's see, trees sim. And let's do v1 slash, and here I'm going to do backtick again and just do at loop iter slash, and there we go. We can, if you middle click, we can see it. It's empty right now, but we're going to fix that. And I suppose the easiest way would be to just go to this. This is where our scatter is. So if we just copy this parameter, go here and paste relative reference, we get 10. Perfect. And if we generate this node, and we can see here, we middle click, I'm tired. We can see we have different values here. So if you want to see it, if we click on one and go back, we should now be able to see here that now it's 0 here, which is perfect. This is what it should be. Let's see, 0. Great. And now I'm just hoping that, by the way, you can do Shift D to like dirty the node. We can just have it like this. We don't have to generate it. Let's see. Are we good? Are we good? I think we are. I think we are. So I'm just gonna save, and now I'm gonna exit out of this, and let's go to the command line. I'm going to take our URL here, or our path, D colon. So we go to D drive. For me, that's different for you probably. CD, and I'm just going to paste in our path. Again, you know, there we can see we want to H script our file, trees, hip LC, and we're jumping in. And ls, you know, we do cd tasks, ls again, we can see topnet 1. I have topnet 2 as well, but you have topnet 1. This is what we're going to use. And to start this, we do pop a top cook space and then topnet 1. If we press enter now, we should be good to go. I don't know what happened there. Let's see. I don't remember which one it was. 3sim, this is the one. We can see it's generating. Yes, it does. Perfect. And as you can see, we're using 11.7. Now it was done and it like cleared the cache and start over again. So we're reaching like almost 12 gig. I think that's pretty good. And you know, you could have a whole fucking forest if you so want to. Not that you would want to have dynamic trees for a whole forest, but you could have plenty. And then the rest can be just static, copy the point trees that would be like perfectly instanced. But anyways, when I'm done here, we're going to see the result of this. Okay, we're back. Let's go in here. Disable this. I'm just going to do this. Okay, so let's load in our trees. We go in here, we can see 3 sims. If we look at this, okay, maybe it's not being touched. Okay, I was like, God damn, come on now. So some trees aren't really touched. But anyways, we don't want to do like this. We don't want to copy a bunch of these guys. So let's just add a for each, not point, for each number. Put this in here. And if we look at this count in the details, we can have iteration. So we're going to go with iteration and say where there's a 0, we do backtick again. And here we can run the detail function. And the first one is, we want to go up, and then we do the for each count. And then we want to have iteration and 0. And if you want to be even more, you could paste in, like if you want to be all fancy and shit. So we can copy this one and just paste that in here. Paste relative reference, like so. And now we have our trees. This one isn't being touched at all. It's being missed. Okay, so that's that. Let's see how it looks. We're gonna take this. Let's do an object merge. Just gonna merge this guy in. So, and then we do a merge. And let's see, should we create a time or what's it called? Flipbook. Start. Let's see, this is what we have. Looks all right, I think. So we want to go into Solaris. We're not going to do a whole lot of rendering, but we're going to take it in there. Something that I did notice was that probably messed up this one. I never got the velocity. I forgot to add that in. Out animate branches. Out animate branches. Okay, maybe we can just add it in here. And let's just say trail. I think that's fine. And if we go here now, we should now have velocity on our trunks. I mean, not the branches. The branches already had. So that's good. I'm just gonna copy this one, and if we press N, we can go into lobs. And we want to do a SOP import. It's one of the ways of doing it. We're going to paste that in. Let's go into the first frame. Now, I don't think this actually matters. So this is not like instances, right? So it's not really using a lot of memory anyways. So that's pretty fine. It's not perfect, right? But sometimes you can't just have perfect instances. And what I mean by this is if we were to just create something here, let's create, where are our trees? We have it here in the trees. Am I being a pain in the ass now? What is this? Maybe we can use this. I'm gonna take that, go in here, object merge, paste that in here. We want to do, let's say we pack it, and we pack it by 3ID maybe? Can we do I? There we go. If we want to have like UVs or whatever, let's just keep it like this. So these are now packed. We have 4 trees. They're all packed. I think we can use explode. Yeah. So you can see we're exploding them. All fine and dandy. You do a grid. Then copy to points. And let's see. I didn't click this. Make this bigger. Like so. We do a scatter. Scatter, let's say 10 of these. And target, we want to copy this. Oh yeah, now I'm kind of messed up here, probably. Let's see, now we're just copying one of them. ID maybe. Integer, this was a long-winded thing, okay. Variation, yes, or variant. Let's set this to random from 0 to 3. There we go. But Jesus. Don't need this. We can do a pact. I don't think we have to do this. Is this faster? Yeah, this is faster. Okay, that's cool. I'm just gonna copy this. Go into our stage. Gonna make this like so. And here we see this is like proper. For some reason, okay, we only have 3 of the trees. Okay, tree ID. Tree ID. There we go. Do we have 16? 16, 17, 18, 19. Okay, we have all the trees now. And you can see we have prototypes here. And these, if you ever see, like, use as many prototype as you have these guys, then you're doing something wrong, and that is bad. So these are the 4 trees that we have, and then we are scattering those. They are referencing the prototypes. So this means that we can basically have a fucking forest filled with however many we want, and it's not going to be much of an issue now. Of course, like it's a lot here, but it should be okay to render with. See how it renders perfectly. Obviously it looks like trash, but this is perfect instances. And there's ways of doing this without the copy to point, but it's like, if you, I'm going off a tangent here, but if you do these kind of things, like you have a box, ISO offset, scatter, Voronoi fracture. So we have, can we make it bigger? We have 1,000 pieces here. These are not going to be true instances. So even when you do, like, usually we have, like, we're packing it and all nice, and it's great and all, and it is going to give you some benefits being packed and all, but it's not a true instance. So, oops. So I'm gonna copy this stage, paste that in. it's like this. You see here, we have 1,000 pieces, shitload of them, and we have just as many here. We have to 9. It's all, well, looks like it's the same. Yeah. This is like trash. Okay, this is not going to give you anything. You could have just as well done, I guess, this, or just like Xform. This is basically just, you know, this is better than having it like this. At least from my tests. But anyways, if you see this, you have just as many prototypes. It's not going to be proper instances. But anyways, back to topic. We have this. Maybe we should first, no, let's just build something. If you are new to this, it's not going to be really a render tutorial here, but we can merge these guys in like so. We can make this larger, beautiful. And maybe we want to have a camera, maybe we can do that here. So new camera. And if we have it locked, that means that we can move it. If we have it unlocked, you know, the camera is going to stay where it should be. We can always make it bigger. We can see. Oof, okay. Why am I always doing something that I shouldn't be doing? This is why I never get anywhere with Houdini. But something like that, right? So then we want to have a light. There's a lot of different lights. You can have your own HDRI with the dome environment type of stuff. We can use the, what's it called? Physics. I kind of like Karma Physical Sky. It's kind of nice. Not going to look at it. Before that, just add a Karma. This is basically when we're going to render this out. It's going to use the settings here. But we can just, I mean, we are going to use it here as well. Before we render, we want to press D here and pick viewport size. Otherwise, you're going to get, it's going to be like, it's going to use this. So if you have a bigger window than this, it's going to be really blurry. So viewport makes it, you know, whatever resolution this is. If we turn on, we can see our beautiful little tree farm. Change this. This is the, well, it's changing the blurriness of the shadows. This is going to be on the side. Let's, where do we want it? Give it a little more shadow like that, maybe. Sky. I already know what this does. Let's up the intensity. Maybe something like this. Noise. Where were I? Yeah, we can, I think before we just slap on this, the materials, we can change these guys that we see here. This is the path that we have. So if we go to our, not this one, what we can do is, I think it was on the primitive. I've pinned this now, so it's not going to change. If we do as at path equal sprint f, which is a very useful function, it's basically And I always do this wrong. What is it? I think it's like this. And because we added this percent sign S for string, we can just, we can say something like this. See how it changed? Obviously, we don't want to have a static thing. You know, maybe we would do the path, and then, you know, this would be I for integer. Then we can add another one. And this would be maybe the ID, for example, as you can see. What I'm thinking is, let's see. We have, so ID is, each of these have an ID. So maybe we should just do, how should we do it? Three I, and then if we do slash, you'll see what happens soon. ID, and we can use the 3 ID here. This is going to give us like so. So now there's one way of kind of sorting things out. Maybe it's not the nicest way, but it's one way of doing it. So now we have all separate. So if we go in here and we create a material library, just clear this, we can create a material. We're going to have a leaf. This is going to be the same for all of them. The branches is also going to be the same. Branches. Or maybe we can just duplicate that later. Let's see. Image. Pop that into the base color. Now we just have to find the maps. And then we can just pick this. Now we have that. We can copy this. And we can take the opacity that's in the geometry here. And that's a float because it's a black and white image. And then we can do the bump, bumpity bump. If we type bump, we're gonna get like a converter thing. So we put that into the height and then out to normal. That's that. And I'm gonna skip the other one. Or did we have any more interesting? It's pretty shitty stuff here, but I mean, I guess we could use the bump for specular. Let's do specular roughness on that one. And if you wanted to, we could add subsurface as well, but so we have that. Let's see. Sort this out a little. Shift S. Something like that. And then we can just copy this. And this is branch. And this one is going to be, I think these are the branches. Opacity we don't need. Specular, I don't know if we have. We have bump. Let's add it on the bump for why not? And this is also the bump. Float, yes. Height, cool. If you start with that, what we can do now, if I just like, I pick the leaf on the leaf. Now, of course, it's just going to give it to this specific one. But what we can do is we can use stars, which is basically like anything. So it has to be 3 underscore anything and then leaf underscore anything. Now all of them gets it. So we would do the same thing on this one. Just change this to branch like so. Now those got the branches. And of course, then we have the trunk. So this is not like the most, you know, automatic way of doing it. Maybe we could have used some sort of like geometry property, so it's going to read from the geometry. This is also how you can get some nice variation on the leaf's color. So you can have like, you can take a value that you've created on each leaf, and it's going to like maybe be piped in into color correct something, you know, and you put it somewhere where it fits. That's kind of cool, but we might skip that one. Let's just call this trunk 16. And let's go with the trunk. This is the trunk, yes. This one. And I'm just, did we even have a nice, we have the bump. Let's just go with the bump for the specular roughness. And we can just pipe that in here as well for this. And there we go, and copy this and change these guys to 17. It's so automatic, don't you think? Not really. Sometimes it's just quicker to do it like this. So that's why we're doing it. So that's 19, works. 18, 17, cool. Now we just autofill again. And here we can do trunk. This trunk 19. Then we do star here. This would be the 18. This would be 17. Whoa. That was my computer scaring the shit out of me. And there we go. I need to check on my computer. I don't know what's going on with it. I don't like the specular. So what happened? We need to reset. Yeah, I don't know what's going on with the fucking viewport. It's a typical Houdini thing. Let's render. Look at the camera. Camera, thank you. It's moving closer. And there we go. Ah, did I not change that? What is going? Oh, it's because I reset. Could be. Okay, so there we go. Not the most fun thing. I kind of like to do, which I know is pretty wrong, but doing the aces. But it's like, we're kind of seeing aces. You probably have this as well. Maybe you don't, but... And then I'm like adding in on top of that. So it's, I guess it's kind of wrong to do it, but I like it. We have denoising if we want to do that. From my test, Intel seems to be the best that handles like a lot of details, but it might be on a case-by-case basis. It is really good to get rid of noise, but you're not going to be able to like have 16 and just like denoise and think that's going to look good. There's a lot of shit that is going to disappear. So yeah, let's see what else kind of cool stuff is there. Yeah, there's I don't know, right now I'm just like wasting your time. Maybe we can add a little bit of a blender to the thing, something that You see a lot in Blender renders, which I really like. It's fog. But, you know, it's gonna depend on the lighting as well. A little bit. That's nice. I like it. And then you can have like a spotlight going on here, and you get some god rays through the leaves or whatever. Let's make it bigger. Anyways, let's look at what's it called? It's called motion blur. That's the word. We have that somewhere. Camera effects. Let's do velocity motion blur. We should now have motion blur. If you want to, you can do like render region. So we can like do this. It's gonna just render that one. And it's dependent on the velocity, of course, but also on your camera. So making sure that you actually are on the camera. I do that a lot when I'm not in camera. And why the hell is it working anyway? I didn't think it was gonna work. Okay, sometimes, I don't know. I don't know nothing. Okay, that's weird. I guess we have motion blur anyway, so. Okay. But anyways, bigger number here. Obviously gonna give you a big motion blur here. Super nice. Let's reset that. You can also like multiply the velocity. Look here. We can just say like v at or at v times equal. Maybe you want to lower it. You can just half it. You know, if it's too much. Let's do a more extreme value. Why does it look like I have velocity? Oh, it's on primitives. Or I mean points. There we go. So now we don't have any velocity. Now we have a lot of velocity. 0.75, you know, that's a way of doing it. I also kind of like the lens shader. Can look at that. So now it's easier to do it. Before you had to create like a, what was it? Was it VOP network? Can't remember. Camera, no, it's not that one. No. Chop. Is it a material? Yeah, Karma Fiscal. You had to do it here before, but now you can just create one here. It's going to create this node. And I really like the chromatic, but it's going to add to the render time for sure. And you have to have a little. But I think it looks super nice. It can be done in post, so I don't know. This as well, if I could ever understand it. It can be cool. Add a little bit of that. Why not? I don't really understand it though. I suppose you can create some sort of anamorphic lens here somehow, but I don't know how. We add this in, and we're in heaven. Oof. You know, with noise, then it's gonna be even harder to render this out. But I do like it, not gonna lie. Probably too much though. And before we go on, let's just for the fun of it also create a light. See if we are able to get some God rays here. We're not there, that's good. I'm not a huge fan of the gizmos in Houdini. I don't really understand it. Like so. Let's see. Let's start off by rendering. Let's see. Let's do a shaping, focus maybe. Just focus it. Can we get some God rays? Come on. Oh, that's too strong. Let's remove the lens shader for now. Anyways, you can create it. You just have to work at it a little bit. Can I make this smaller? I need more graphic cards. Can't have just one. Way too strong. Anyways, I'm not going to bother with this. It requires a lot more love. But I do like the fog. Okay, so what else is there? So you want to render this out something? Well, first of all, you have in the output, we can do AOVs and you can see them here. But you have to render. Then you can like see the depth and whatnot. So that is one thing that you can do. The resolution, set it to manual, set it whatever you want. We have the path to where it's going to save. We have this. We're going to use this. This is going to use the settings. As you can see here, if we go here, you can see the render settings. Remember when if you wonder like, okay, where are my stuff? It's because like it's gonna show you this node and whatever is above. So if you want to see everything, then make sure to be on the last one. Yeah, There, another useful is prune if you want to remove stuff. So you can be like, I don't know, say you want to remove the leaves. Do that. And now, you know, all the leaves are gone. A nice one. Anyways, if you are rendering from here and not from the from the terminal, you can turn on and play monitor when you render to disk so you can see it. If we were to, let's see, we can just have the current frame, render to disk, see if it works. You never know. There it is. Perfecto. Now we can see it. So otherwise you wouldn't be able to see this. It's going to turn this off. And there's probably a way of doing this. Like, I'm not sure if this is caching something. I don't think it should cache anything. But if it is, there's probably a way of doing this in tasks for it to like perfectly like clear the cache all the time. But it shouldn't, I don't think. But anyways, if we save this now and we exit and we start the command line, we can now do d:/cd and then h script to go into our trees. Again, we have done this many times now. And if we look, we can see we have stage. So cd stage, and if ls, we can see our US render ROP1. So we do render USD render underscore ROP1. And if I do this now, it's going to do the render. And one thing that I noticed was like I saved a lot of memory. Not only like obviously on the regular memory, but on the GPU because we run with XPU. Like it uses like half. I went from like 7 gig to 3 gig or something in my previous test. So you're saving a lot of memory. So do this if you once you've done your tests and whatnot, then just save, close Houdini and do the rendering here. So much better. Yeah. But anyways, that is probably it for this tutorial. Hopefully it was somewhat helpful. We're going to continue on with using these trees in another, like we're going to do ground destruction and whatnot. I just wanted this to be a standalone tutorial. And hopefully you learned something. Yeah. Thanks for watching it and for joining the Patreon. Bye-bye.